Welcome. Now, in continuation to the previous slide, that is, we have seen table number 4 for service factor for speed reduction gearboxes, table number 5 examples of driving machines with different working characteristics. Similarly, table 6 examples of driven machines with different working characteristics. In continuation to this, now we will see the expression of effective load. When gears rotate at very low speed, almost at zero velocity, the transmitted load Pt can be considered to be the actual force present between two meshing teeth. However, in most of the cases, the gears rotate at an appreciable speed and it becomes necessary to consider the dynamic force resulting from the impact between the mating teeth. First of all, I will explain, then I will tell you to write down this. The dynamic force is induced due to the following factors. First, inaccuracies of the tooth profile, errors in tooth spacing, misalignment between bearings, elasticity of parts, and inertia of rotating discs. There are, in general, two methods to account for the dynamic load. First, approximate estimation by the velocity factor in the preliminary stages of gear design, and precise means exact calculation by Buckingham's equation in the final stages of gear design. Therefore, it is difficult to calculate the exact magnitude of dynamic load in the preliminary stages of gear design. To overcome this, a velocity factor CV developed by Barth is used. The values of the velocity factor are as follows. These values are for different velocities. Therefore, first, for ordinary and commercially cut gears made with form cutters and with V less than, V means pitch line velocity or surface velocity, V is less than 10 meter per second. Therefore, CV is equal to 3 divided by 3 plus V. This formula is generally given in the problem. No need to remember this. For accurately hobbed and generated gears with V less than 20 meter per second, CV is equal to 6 divided by 6 plus V. And third, for precision gears with shaving, grinding and lapping operations and with V greater than 20 meter per second, CV is equal to 5.6 divided by 5.6 plus root V. Therefore, the pitch line velocity is given by V is equal to pi dn upon 60,000, where d is equal to pitch circle diameter in millimeter, n is equal to speed in rpm. Therefore, the effective load between two meshing teeth is given by P effective is equal to CSPT upon CV. Service factor is also provided in the problem. The velocity factor is an empirical relationship between developed by past experience. This method of calculating the dynamic load has the following advantages. First, it is much easier to calculate the velocity factor and design gears. Second, velocity factors have sanctions of the American Gear Manufacturing Association. Third, they were used in the past for many years and given satisfactory results. The disadvantages of the velocity factor method are as follows. First, the dynamic load depends upon a number of factors such as the mass of gears, mass of mass connected to the gear shaft, and properties of the gear material like modulus of elasticity. A gear tooth of a material with low modulus of elasticity will deflect more than the gear tooth of a material with high modulus of elasticity, and other things being equal will absorb the energy of impact and reduce the dynamic load. Velocity factor method neglects these factors. It assumes that dynamic load depends only upon pitch line velocity. Second, use of velocity factor is restricted to a limited range of pitch line velocities. It is not possible to extrapolate the values. In the final stages of gear design, when gear dimensions are known, errors specified, and the quality of gears determined, the dynamic load is calculated by equations derived by Earl Buckingham. The effective load is given by P effective is equal to CSPD the values of the gears, means dimensions of gears we are knowing. While solving problems, you will understand we are going to solve many problems where TD is the dynamic load or additional load due to dynamic conditions between two meshing teeth. Therefore, this is the expression of effective load. Now you just start writing from this slide. I will wait 5 minutes and then I will take dynamic load, and tomorrow I will take wear strength, and afterwards, after one lecture, we are going to solve problems on the spur gear design. Therefore, start writing from this slide. I will wait 5 minutes for each slide. Start writing. Hello. I think you have written. Therefore, in the preliminary stage of grid design, we have to use the formula P effective is equal to CSPT upon CV. And in the final stages of gear design, when we are knowing all the dimensions of the gears, that is module, then pitch circle diameter, number of teeth, addendum circle diameter, dedendum circle diameter, all the dimensions when we are knowing, then we can use the formula P effective is equal to CSPT plus PD, where PD is the dynamic load or additional load due to dynamic conditions between two meshing teeth. Now we will see the formulas how to find out PD, that is dynamic load. Therefore, next point is effective load by Scott's equation, that is precise estimation. Therefore, we are knowing the formula P effective is equal to CSPT plus PD. Therefore, depending upon the materials of the pinion and gear, there are three equations for the dynamic load. First, for steel pinion and steel gear, PD is equal to ENPZP into B into R1 R2 divided by 2530 into square root of R1 square plus R2 square. For cast iron pinion and cast iron gear, PD is equal to ENPZP into B into R1 R2 divided by 3785 into square root of R1 square plus R2 square. And for steel pinion and cast iron gear, PD, that is dynamic load PD, is equal to ENPZP into B R1 R2 divided by 3260 into square root of R1 square plus 0.92 R2 square. Now you may be thinking that what is meant by E, N, P, Z, P, B, R1, R2. Therefore, I will explain. E is nothing but total error, where E is equal to EP plus EG. That is error in pinion plus error in gear is equal to total error. That formula is there. We will say NP is nothing but speed of the pinion. ZP is nothing but number of teeth on pinion. B means face width. Its value is generally 10 times module, means 10 into module. R1 is nothing but pitch circle radius of pinion. R2 is nothing but pitch circle radius of gear. Therefore, write down these formulas and we will see next. I will wait for 5 minutes. Please write down. Therefore, next, the incremental dynamic load PD calculated by Buckingham's equation is far more than the corresponding load calculated by the velocity factor method. Very often, it is 3 to 4 times the, the tangential load due to power transmission. It has been observed that in most of the practical cases, the actual dynamic load is less than that of the calculated values by Buckingham's equation. This is because the equation is mainly applicable to large gears with connected masses that rotate at moderate speeds. Therefore, the actual dynamic load is less in the following cases. First, small gears transmitting low power. Second, high speed light load gears, small gears on small shaft, gear shafts up to 50 mm diameter, and small gears transmitting less than 15 kilowatt of power. Gears on small diameter shaft easily twist through an angle equivalent to the effective tooth error and the dynamic load is reduced. Therefore, the error E is given by, already I had told to you, E is equal to EP plus EG, where EP is equal to error for pinion and EG is equal to error for gear. The error depends upon the quality of the gear and the method of manufacture. There are 12 different grades from grade 1 to grade 12 in decreasing order of precision 7. The expected error on the gear tooth is considered to be equal to tolerance. Therefore, these errors we have to calculate in mm. Therefore, total error E is equal to EP plus EG. That formula is there for the error, how to calculate. Therefore, the tolerances for adjacent pitch error E are given in table 7. These tolerances are calculated by using the following basic equation. Phi is equal to m plus 0.25 into root d, where phi is equal to tolerance factor, m is equal to module in mm, and d is equal to pitch circle diameter in mm. While solving the problems, we have to use these equations, that is E is equal to EP plus EG. Write down that E is equal to EP plus EG, where EP is equal to error for pinion, EG is equal to error for gear. Then write down this formula. Phi is equal to m plus 0.25 into root d. Phi is equal to tolerance factor. M is equal to module in mm. D is equal to pitch circle diameter in mm. Write down this formula. Then these are the value of the tolerance on the adjacent pitch for different grades. Now these grades are the manufacturing grades. Which manufacturing method is used to machine the gears or to manufacture the gears? According to that, these grades are there. Now that value of E in microns we are getting for grade 1 0.8 plus 0.06 into 5, for grade 2 1.25 plus 0.15, for grade 3 2 plus 0.165, for grade 4 3.25 3.20 plus 0.255, for grade 5 5 plus 0.45, for grade 6 8 plus 0.635. These grades are provided in the problem, that is statement is like this: gears are manufactured by using grade 7. Therefore, They have provided this equation. Therefore, you can use E is equal to 11 plus 0.95, and you have to substitute value of phi here. That is, phi is equal to m plus 0.25 d. Then we will get error in pinion, error in gear, and that two errors we have to add. We will get final error E. This is not final error E. Remember, this is the equation for E. For grade 10, 32 plus 2.55. For grade 11, 45 plus 3.555. For grade 12, error is equal to 63 plus 55. Therefore, this is the table of grade and corresponding error. The method of manufacture for gears depends upon the grade of the gear. Gears of grade 11 and 12 are manufactured by casting. Gears of grade 8 and 9 require rough and fine hobbing. Gears of grade 6 are obtained by hobbing and rough grinding, while grade 4 requires shaving and finish grinding. Therefore, this is nothing but grade and their manufacturing methods. Therefore, we will stop here. Enter your numbers, and those who want to write down, they can write down these different grades. What is meant by grades of the gears and different manufacturing methods. And we will stop here.